Welcome, ladies and gentlemen, to this SQLBase 11.7 webinar. We are going to talk about the new database drivers of SQLBase 11.7. I'm your host, Martin Tetz, and I will guide you through this webinar. Our speaker today is Dennis Norgård, which is the manager of SQLBase development, who has more than 20 years experience with writing code for SQLBase and managing SQLBase development. We will give you a chance to have your questions answered. To do that, I'd like to ask you to use the WebEx Q&A tool that you find in your WebEx toolbar, or you can put your questions into the chat tool of WebEx. We probably will only reply to your questions at the end of the webinar, so don't worry, post them. They will not get lost, but we will answer all of them at the end of this webinar. And with that, I would like to introduce Dennis, who will be doing the presentation of this webinar today. So I'm changing Dennis' role to presenter. Dennis, please go ahead.
Okay. Let's see. Can you hear me?
Yes.
Welcome, everybody. My name is Dennis Norgård, and I'm the manager of the database development at Gupta Technologies. What we're talking about today are the SQLBase 11.7 database drivers. So I'm just going to jump right in. One of the big changes that we made in SQLBase 11.7 is we've combined all of the ancillary files into single file client interfaces. And this is a list of our interfaces that we support in SQLBase 11.7. And these interfaces existed in prior versions, but in this version they are easier to deploy to your client machines and more flexible in the ways that you can modify your software to connect to SQLBase. So the first one here is SQLWNTM.dll, and this is the core SQLBase interface, the one that's been around forever, supports C and C++. And this interface used to be a whole set of files, and now this is a self-contained single file interface. The next two are the ODBC and OLADB, and in prior versions these required that the SQLWNTM.dll were present. New for 11.7 is that these files too are self-contained and do not require other files to be present to be used. The Gupta SQLBase.data.dll is a brand new .NET data provider. We had one before, but it was also built on top of SQLWNTM.dll. In SQLBase 11.7, it's written entirely in C#, so it's a managed code library. And this means that it can work with 32-bit and 64-bit applications. The first three DLLs that you see, each of those has a 32-bit version and a 64-bit version. So there's two of each of those, and there's one .NET data provider. And then the last one is our JDBC driver, which is a single file. So I'm kind of jumping off a cliff here just to talk about error messages briefly, because error.sql was one of the ancillary files that you had to deploy with your client component. And the error is an example of how we combined all these files into a single deployable client DLL. And all the error messages for English are built into each of the dynamic libraries. And if you want to override them, you can provide a replacement error.sql file just as before, or you can use the resource editor to change them. Now, if you use the resource editor to change them, you would break the signature on the DLL, but right now we don't have a signed. In the future, we'll probably have a signed DLL, but that will still allow it to work. And I'm just going to show an example of what I mean here. So if I go into a directory here, and I'll just copy SQLWNTM to a temporary directory, and SQLETX into a temporary directory. And so in this directory, I now have everything I need to compile this program. And this program right here is just simple. It just hard codes error 127, passes it to SQLETX, and displays the error. So partly what I'm demonstrating here is that I have a simple environment to build this with. So if I compile SQLETX and link it with SQLNTM.lib, all required was SQLBase.h and the lib file. So now I can actually run it, and I can say I want to look at error 127 and see that I do have that error. If I want to change that error, I can copy a replacement error file in and go down to and change the text. So now if I run SQLETX, I see there's a new error message. If I delete the error, and that would allow you to convert it to a different language. Now I deleted the error file, and it's back to the built-in error. If I bring up the Dev Studio on SQLWNTM.dll, you can use the resource editor to change the built-in errors. And this is a new error. And this is just a practical matter sometimes when you're deploying a client to allow maybe if there's a confusing error message to change it to something that could help your end user. So now if I save this, exit, now when I run the same program, I see that there is a new error message. And if I delete all the other files, you'll see that here is my client component, and all it requires is one executable and one DLL. So this is a pretty large simplification from prior versions of SQLBase. So also in SQLBase 11.7, we've added Namepipe communication, and I view Namepipe communication as a replacement for anonymous pipe. We have a SQLApipe interface that uses Windows anonymous pipes to communicate between the client and the server. And that has always been, that has been getting increasingly difficult to maintain because Windows keeps increasing the security of inter-process communication. And the APIPE interface in order to create a connection, has to find another way to talk to between the client and the server to pass anonymous pipe handles back and forth. So what we've done is we've created a natural pipe interface for Windows, the Namepipe interface. And we've also made this able to automatically find servers on your local machine. We've also allowed you to choose whether or not you want to use a SQL.ini file. We still support the SQL.ini file as we have in prior versions, but you now have the ability to avoid using it altogether for the client. We've added external authentication so that you can authenticate between the client and the server using Windows to manage your authentication. This allows you to not have to store a user's password in the database. And we've improved the tracking, the ability to determine which clients are using the server. So Namepipes is a replacement for APIPE. We will continue to support APIPE for backwards compatibility purposes. But the Namepipe interface works on both local and remote machines, and you can restrict it to local-only connections. It has a little advantage over TCP in that you don't have to assign a port number for your connections. Windows provides built-in access control for remote connections, and what that means is if your client is attempting to connect to the server, in order for the connection of the Namepipe connection to succeed, the server has to be able to identify the client. And this all happens before the SQLBase sends the database connect message across. So this can make it a little tricky. When it doesn't work, you have to understand that Windows can block it, and you have to provide access from Windows. But it also allows you to have an extra level of access control where you can't even attempt to connect to the server unless you have authentication through Windows. We'll show the Namepipe interface a little bit more later. So the next thing is on our configuration, we have a SQLini file, and what I try to show down here is that we've had this Win32 client.dll, and we have the COM DLLs. This is SQLAPipe, which is anonymous pipes, and this one is Windows Sockets 32, which is TCP IPv4. We no longer have these DLLs because we've combined everything into single file client components. And we will still read legacy SQLini files, and we'll interpret them. So if we see a COM DLL equals SQLAPipe, we'll interpret that to say he wants to use anonymous pipes, but we're not going to load a DLL. We'll just make a note of what's being requested. And so this will still work. But the new way would be in the Win32 client section to just specify which transports you want to try in the order that you want to try them in. So we have Namepipes, we have TCP IPv4, SQLBase 11.7 now supports TCP IPv6, and we still support anonymous pipes. Namepipes and APIPE only work on Windows, where TCP IPv4 and IPv6 work on both Windows and Linux. So I just wanted to show that we have a SQL.ini file that's set up the way that we've done it in the past. And here I show that I also can specify Namepipe, and these sections are the same as before. So if I connect to, I have a little sample program that will allow me to connect to Island, and I can specify the SQLini file. So I have a server running already that right here will show that I connected using that SQLini file and is connecting through Namepipe. If I modify this SQLini file to use transports instead of this way, it should still connect. And you'll see that on this line here, I'll be connected to Namepipe in this case. And that's because the transport said do Namepipe first. Yeah, okay. On this one, it said try Namepipe before Namepipe, and this one I said try Namepipe first. So these communication DLLs still work, but this is the new way to specify which transports you are using. So as I said before, the SQLini, you can continue using it, or you can get rid of it. And if you get rid of it, you have to provide all the connection information in the connection string to the client. And we do this, we still support a connection string where you have database name / username / password. But now we also allow you to specify name-value pairs. And the name-value pair combinations have these keywords. You can specify the database name, so database equal Island, for example. And depending on which interface you're using, there may be other synonyms you might want to use in place of database name, such as initial catalog. So all of these names work as a synonym to database. You can specify username or any of these for the username, password. The transport is Namepipe, Namepipe, TCP v4, TCP v6, and then we have the server name. The server name is not required for a TCP connection because you specify the TCP connection with the host name and the port number. But if you're using name pipes, the server name can help make that connection. We also support SSL, and there are some SSL parameters that can be specified. So here are some sample connection strings that can be passed to the connect function. And the first one is an example where we're using TCP. We specify the database as Island. The transport, TCP is TCP IPv4 by default because that's the one that has the most history. You could also say WS32 there as a synonym, but TCP, TCP v6, and you have to specify the host name and the port number. We don't provide a default port number when you're using the connection string. If you're using Namepipe, you could specify the transport as Namepipe, and the host name is needed if you're that tells you what you specify which machine that you want to connect to, and you can use the DNS name. And the server name is part of the Namepipe connection. So when you specify the server name, it combines the server name, the host name, and the database name to find that server. If you are running one instance of the server name is optional. There is a default instance name for machines that have one SQL-based server running. And anonymous pipe has the same, it only requires a server name, it only runs on one machine, so the machine name isn't needed. We also support authenticated connections, and for an authenticated connection, the username is specified as an asterisk. The reason why we specify an asterisk as a username is, in the past, SQLBase, if you don't specify a username, it defaults to sysadmin. And in order to not break all those dependencies of people assuming we're connecting to sysadmin, we allow you to specify an asterisk as a username to say, you figure it out and connect using Windows. If you're using SSL encrypted communication, you can specify SSL equal always or never or negotiate. So just to show you what I'm talking about here, I have this little connect simple program that takes the command line arguments and passes them to the SQLBase API function, SQLCNC. And by default, I connect to Island, but I can also specify a SQLini file. So just to show you, if I connect to island/sysadmin/sysadmin, it says it's not using a SQLini file, and it connected to Namepipe, and you'll see that the client name is Wisdom, and the client process ID is this number here. Now, I did not use a SQL.ini file. If you look in the SQL.ini file that I have, client name is Fred. So if I do the same connection, but I say ini equal SQL.ini, you'll see that Fred shows up because it's using the SQL.ini file. Now, if I back this up and say I want to use one of these new connection string thingies, I can say database equal island, username equal sysadmin, which is a default. I want to say I want to transport. I want the transport to be TCP. Host name equal localhost, and port is equal to 2155. And here you'll see that it's using TCP IPv4. I can change the transport to IPv6 and also connect. Now, localhost on Windows maps okay for TCP, IPv4, and IPv6, but the host name for IPv6 or localhost is, I believe it's bracket ::1 bracket. For Windows, we require the bracket to be put around the IPv6 address so that we know this is specifically for IPv6. If you just say I want transport equal Namepipe server name equal rabbit, that's the name of the server, it was able to find the server rabbit on my local machine. I didn't require a host name. So this, all these connections here allowed me to connect without using the SQLNI file. If I tried to connect to TCP without a host name or a port number, I get the error, cannot open database. So we have the Namepipe communication, and we allow you to choose whether or not you want to use the SQLNI file. Next, we wanted to show you how we can use external authentication and how we can trace our clients back to our server back to the client. So for our external authentication, we use SQLBase commands to grant connect to a database name, a username, and we map that SQLBase username to network credentials. And we require that for every network name that there actually is a database name mapped along with it. This may improve in the future, but this is our starting point. And we require this mapping between a database username and a network username because we use the database names as they have been. They have limits on the characters and the size. They're part of the auditing and the internal structures. So the network name can be larger and it wouldn't fit into the schema that we're using right now. You'll see that you can specify the network name as domain/username, or you can specify just the username without the domain. If you specify the domain username, then the authentication has to be the domain and the username. But if you specify only the username, that user can exist as an off-domain user or a user on any domain that's authenticated to that machine. So you have a little bit of flexibility to be stricter in a domain environment or a little less strict in a non-domain environment. As I said before, use asterisk as the specifier for the username to say that you want a authenticated connection. What I'll do here is I'll just demonstrate this, and I'll go over to SQL Talk, and I'll just follow the same thing where I'm going to connect to Island and grant connect to Dennis, identified by external. My username is Dinorgord, and I can say grant resources to Dennis, and I can even say grant DBA to Dennis. So now I have a user named Dennis that's identified by Dinorgord. And if I showed the server connection here, I'll disconnect all, and now I want to connect to Island. Star is to use my network username, and I have no password. I'm going to connect, And here on the server screen, it says, I'm connected from Machine Wisdom. The username is Dennis, which is the one that I've mapped my user credential to, and it connected over Namepipe. This allows you to not have your network user passwords stored in the database. All that's stored in the database is the name, Dean Orgord. And I can't show the domain connection because I'm not on the domain right now. So this just shows that we do have some network authentication implemented in SQLBase. And what I've already kind of alluded to is if you have a problem with a particular client, you have the ability to track it back to the user. So because I didn't specify a client name in the SQLini, it now defaults to the computer name, and we have the client process ID, which you and I know that it's this version of SQL Talk. So if I go to Machine Wisdom and bring up the Task Manager and look for process 2436, 2436, it's a 32-bit version of SQL Talk, and if I wanted to kill the process, I could say end this process and mercilessly kill it. It'll go away on the server. So that could be a help sometimes for diagnosing problems like this. Or you know, if somebody has the server locked up with locks and they've left, you have a way to go kill it. I just showed that. We also have simpler 32-bit, 64-bit ODBC client registration and DSN configuration. And we've integrated these new SQL-based features 11.7 into TD. And I could just show you just briefly here about our ODBC interface. I'll leave that up. I have the ODBC driver installed already, and if I want to say add a new DSN, I can go down to, this is the 32-bit version of the ODBC driver, and I can create a DSN island. The database name is island, server name is rabbit. I can say the username is use network authentication. I don't have to specify SQLini. I can specify the connection string parameters so that I can explicitly specify a TCP port number and host name. But I'm running on a machine that has a server and a client, so I should be able to just connect to Island successfully because I've already created the authenticated user, Dennis. So right here I'm connected, I can show the server, it identified me as Dennis. And with that, I can show that I have this little sample program that connects to the DSN of Island without a user ID or password. And if I can compile the sample with, oh yeah, I don't need any local include files or libraries. This is a Windows program, so I compile it. and I can run the sample. And you can see that it connected, it figured out my network name. I'm using Namepipe interface. There's a client machine and there's the process. So I'm just showing you that the ODBC can be a lot easier to deploy and configure and use for the client side of your equation. And so that's just a brief look at the ODBC. So in summary, I just wanted to show you that we have single file client components, and this makes it easier and less costly to deploy out in the field. If you examine the version number of a client DLL, you know that it's self-contained, it's got everything you need, and no mismatching of one version of one file, another version of a different file. We have simplified local communication using name pipes. You don't have to have everything fully specified in order for the client to locate the server and connect to the database. You can connect using a legacy SQL.ini file, or you can use connection strings and avoid the SQL.ini file. We now support Windows Authentication, and we have the ability to help the administrator locate clients that are connected to the server. Those are just some of the things that we've improved in for SQLBase 11.7. And that's it. Any questions?
Please put your questions into the WebEx Q&A tool or into the chat. So I'm switching to my desktop now just for the last few things on this webinar. It looks like the new drivers are really simple. There are no questions at all, Dennis. So
well, nothing simple, but they are simpler, and we'll make them even simpler.
Well, at this point, I think we can end it. There are no questions. People understand what they can do with these new database drivers, including network authentication. So then thank you very much, Dennis, for this presentation. To all the participants, thank you for joining us. I wish you a Merry Christmas and Happy New Year. And looking forward to meet all of you next year and talk to you in webinars and events and so on. Thank you very much, and have a good day. Bye-bye.